Hi everyone and welcome to the videos on the binomial distribution. So we're getting stuck into chapter 14 of the book today, and yeah, pretty much going to go over how to use this rule. It's a fairly short exercise, so I'm hoping to only have just a couple of videos for this one. So to get us started, find the probability of obtaining exactly 5 heads when a fair coin is tossed 8 times. Now there's a number of different ways that we could do a problem like this. So we could start off drawing a tree diagram. So have one branch, we can have heads or tails, and then that's going to branch again for the second toss into heads or tails. And you can see this is going to take quite a while, because if we're tossing the coin 8 times, we're going to have something like 256 possible outcomes. So we're going to be drawing for ages here, and obviously I don't have enough room to do something like that, so this is just rubbish. Okay, you don't want to have to do something like that. Now luckily for us, there was a genius back in ye old day who said that the probability of x equaling x is equal to ncx multiplied by p to the x multiplied by q to the n minus x. And this was quite a nice rule, and it allowed them to calculate binomial probabilities. So a couple of things we need to know about this rule. Okay, firstly we need to know the ncx part. Now that comes actually, that's going all the way back to Pascal's triangle, which we looked at earlier in the year. But remember, that's the triangle that goes 1 and then 1 1 and then 1 2 1 and 1 3 3 1 and so on, where it's made by each of these numbers coming from the sum of the two numbers above it. So this here is 0C0, and then this is 1C0, 1C1, 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3. And what that's talking about is if we have, for example, 3 things and we are choosing 2 of them, that's what the C is standing for, okay, well, kind of. But if we have 3 things and we're choosing 2 of them, then there are 3 different ways that we can do that. And I can show that really quickly here. Let's just draw 3 people. 1, 2, 3. Add a woman in there for a bit of gender equality. There we are. So when we've got 3 people like this, we could have, for example, the first 2 people, or we could have the second 2 people, or we could have the first person and the last person. So you can see that there are 3 different ways in which we can select 2 people from that group, and the order in which we choose them isn't important. The other things we need to note here, x is some kind of score that we're going to be looking for. So we'll say x is equal to the number of desired outcomes. We'll also say that p is equal to the probability of the event, and q is the probability of not that event. So, well, I might just write, let's say p dash, okay? So it's not the probability of the event. Also, we need to know n, which is the number of trials. So, in this case, we're looking for 5 heads, so I can write the probability of x equaling 5 is equal to, now we're doing 8 trials, so it's 8C5 multiplied by the probability of getting a head is half, and that gets raised to the power of x, which in this case is 5, and then the probability of not a head, which is a tail, is also half, and that gets raised to the power of n minus x. Now n was 8 trials, and x is 5, so 8 minus 5 is going to be 3. And nice little check that you can do is that these powers here must always add up to the total number of trials. Now there's only a few seconds left in this video, so what I'm going to do is I'm going to finish this one up here. I'm going to do the answer in the next video, as well as an alternate method for working this out. So I will see you then.